Once again, you're welcome to this class, quadratic equation, and today's topic is completely the square. Okay, without much ado, let's begin. We've said completely the square. This is our part 2. We've handled the quadratic factorization in part 1 and the quadratic formula method in part 1. So both factorization and formula method we handled in part 1. Part 2, we're looking at completely the square and probably the graphical method. Now let's take a look. We say quadratic equation of the form ax squared plus bs plus c equal to 0. This is the format, okay, of quadratic equation. So every equation has this similitude. Every equation takes take a look at it looks like this. Ax squared, a is behind the coefficient of s squared, ax squared plus bs plus c. Okay, this is an expression, quadratic expression. Once we say equal to 0, it becomes a quadratic equation. If you write only ax squared plus bs plus c, it's a quadratic expression. The moment you say equal to 0 or equal to anything, it becomes a quadratic equation. Okay, so to solve quadratic equation, we need to be able, let's model. I want to look for probably an example so that we can model in solving this problem. For example, we have s squared plus 10x plus 9. Okay, s squared plus 10x plus 9. This, we start with quadratic expression. Later we make it the equation. So the first one will solve the expression. The b part will solve the equation. So let's do both of them. So to save time, let's do both of them in order to save time. Is that okay? Let's take this. Okay, let's say we have, just now we have s squared, right? Question 1. We have s squared plus 10x plus 9. S squared we have s squared. Yeah, I just wanted to make it a bit bolder. We have s squared plus 10x plus 10x plus 9. So if you have this, we already know that our a is what? If you want to define, a is 1 because it's the coefficient of s squared, and b is 10. B is 10 in this regard. B is 10, right? B is 10 and c is 9. C is 9. So this is a quadratic expression. This is not equation. Why? Because we didn't put equal to anything. If we did say equal to 1, equal to 0, equal to negative number, equal to anything. So since we didn't put equal to, this is a quadratic expression. Now when we solve a quadratic expression, what we do is we take a look at this first two that has x squared and x. We take a look at this. Okay, we take it as a part, like one part, like we segment this into two parts. The one with the coefficient of x and the constant, we break it into two. The one with the coefficient of x and the constant. That's what we do. The constant is a different part. Maybe I highlighted it with a different color. This one is a different part. Okay, we break it into two parts. When we do it completely the square, break it into two different parts. Now what we do is that we take the one with the coefficient of x, the one with the coefficient of x, this one, which is 10. 10 is the coefficient of x. Okay, this number that is the coefficient of x, we half it. Okay, we say these are the condition. Number one, condition 1, half the coefficient of x, half the coefficient of x, half the coefficient. I'll spell it halfway. Coefficient. Okay, half the coefficient of x. So if I half it, I will get what? Half means divide by 2. So this will be equal to, if you half it, become 10 divided by 2. It becomes 10 divided by 2. 10 divided by 2. So it becomes 10 divided by 2. And it becomes 5, right? So if we have the coefficient of x, we get 5. Half it, that's the first condition. Condition number 2. Square it. Square it. Okay, I changed the color to always give that dynamism. Square it. Square the coefficient of x. After you half it, you square it. So we square it. Square it. Square it means we just write 5 to the power of 2. Square means raise it to power 2. Is that okay? You know you already halved it. So now we say square it means you raise it to power 2. The next thing to do is we say add and subtract. Okay, if it's an expression, you add it to both. You add and subtract. Add it to this. You know we broke it to 2 parts. This first part you add it, and also add it. Then you subtract it from here. But if this one was equation, it was on the right side, you subtract it. If this one was moved to the right side, if it was equation, we subtract. Okay, let's follow the format it is. So we say you add it to this block and also add it to this block. You add it to these 2 blocks because they are on the same side. If it was equation, this 9 was on the other side, you subtract it. If this 9 was on the other side, for example, if it was x squared plus 10x equal to negative 9, you've moved 9 to the right side. If it was equation equal to negative 9, as you move 9 to the right, then we would have subtracted it from it. But now we say C condition, add and subtract, or add it to both sides. Add it to both sides, or add and subtract. Add it to both sides. Or in some cases, we write add and subtract. Add/subtract. Okay? And then we solve it. The D condition is now, when you do that, after doing all of this, solve it. Solve it. Now let's look at it. Let's solve it. Let's follow these rules and see what it leads us to. Solve it. Okay? So we have the coefficient of x. We have 5, and we square it, we get 5 squared. So add it to both sides now. But for this one, we are not adding to both sides. You add it here, you subtract it here. Because it's one side, there's no both sides. It's just one side. It's on the left. If it was like this is what I mean by add and subtract. And this is what I mean by adding to both sides. If it was like this, for example, the equation is x squared. The equation is x squared plus 10x plus 10x plus 9. If it was equation, plus 9 equal to 0, you know, we would have done like this. This next step would have been move the constant to the right. It would have been plus 10x equal to, you move this positive 9, you move it to the right, becomes negative 9. It would have been like this if it was equation. And then in this case, you already have the left side, which is this, and you have the right side, which is this. In this case, we say add it here, also add it here. So add it to both sides. This one would have been added to both sides. Add to the left, also add to the right. Add to the left, also add to the right. That would have been this condition. But this condition is a quadratic expression. This one is a quadratic expression. We didn't move the 9 to the right side. So we go to add and subtract. So this is what we're going to have. We have x squared plus 10x Okay, remember it's one of the boxes. You know I said break it to 2 boxes. Okay, now the first box we add the 5 square. We add this 5 square. The first box we add a number to it to join it to become plus 5. You know, this was the first box. We can itemize the box. We can highlight the box. This is the first box. Okay, we add something to it. We add something to it. It becomes we add 5 square to it, to the first box. And then we move to the second box. The second box is what? 9. Right? 9. And then we subtract 5 square from the second box. We say minus. It's like you add to the first box. Now you want to subtract from the second box. Are you with me? Minus 5 square. So the 5 square, you add it to the first box and you subtract it from the second box. That's all you did. That's all you did. That's all you did. So you add it here. This is the second box. Remember, this was the second box. This was the second box. So what we did is that we added 5 to the first box and we subtracted it from the second box. We added it to the first box and then we subtracted it from the second box. That's all we did. It's like plus or minus, so equal to 0. It's like I didn't do anything. I only add it here, subtract it here, which is technically still the same thing. Technically still the same thing. Now we move on. After that, we now see this as 1 unit. We see this as 1 unit, this whole thing. We see it as 1 unit, which now looks like a perfect square. It looks like a perfect square. Why? Why does it look like a perfect square? Because you have x squared plus 10x plus 25. You know, this is like technically 25. 5 squared is 25, not 10. So this is like a perfect square. It's like 5 plus 5, 10. 5 times 5, 25. So this is a perfect square, this first box. So what we do, to factorize this, we have to factorize this. To factorize this, the short way of factorizing this kind of a perfect square is to take this one, take it, x, whatever sign is here. If it's minus, you write minus. If it's plus, you write plus. So you write this plus. Then you take this number, 5. Then you bracket both of them. I'm showing you short way to factorize. Because this one is square, this one is square, you bracket both of them, you square both of them together. What you have done, you factorize this. Because if you break this one down, if you do this factorization, you will get this one. You get x plus 5 in one bracket, and you get x plus 5 in another bracket. So you get x plus 5. X plus 5 bracket square means, what this one means, it means you are having this. It means you have this. X plus 5 together in a bracket. You square it. What it means is this. It's simply this. It means you have x plus 5 in one bracket, x plus 5 in one bracket, and another x plus 5 in another bracket. You have another x plus 5 in another bracket. That's what it means. Square means twice. So when you square it, it means you have to write it twice. Okay, x plus 5 in one bracket and another x plus 5 in another bracket. That's the meaning, because if you square it, it means it's twice. It's just like when you have x squared. Remember, when you have x squared, what it means? It means x multiplied by x. It means x multiplied by, it means x multiplied by x. Similarly, if you have x plus 5 all square, it means x plus 5 in one bracket multiplied by another x plus 5. Right? Logically. Are you with me? Okay, good. So this is what it means. So we come here, and if you expand this one, x plus 5 in one bracket and x plus 5 in another bracket, if you expand this, you're going to get this one. You get x plus 5 squared, x squared plus 10 squared plus 10x plus 25. You're going to get this one. If you expand this s plus 5 squared, you get this whole thing. And then we go to the next one. Then we say plus 9 minus 25. You know, 5 squared is 25. This 5 squared is 25. So we say 9 minus 25. So we'll move to the next step. Next step is we have x plus 5 square, s plus 5 square minus, because 9 minus 25, you're going to get a negative number. 9 minus 25 is like you take away 9 from 25, you put minus behind it. So because the bigger number will carry the minus, we carry the sign. Since 25 has minus and is a bigger number, like number and number. So if you say 9 minus 25, you're going to put minus behind the number, whatever you get. So 25 minus 9, what will you get? You get 16 minus 16. So if you want to find out minus 16 plus 9, you get negative 25. Minus 16 plus 9. Right? Yeah. You get negative 25. So this is what you get. This is where we stop, because it's a quadratic expression. Okay? Not the equation. It means this is your answer. Because when you're doing quadratic, you are being asked to put in this format. I show you the format. They always tell you when you're doing completely square, put in this format, put your answer in this format. S plus P square minus P square minus Q square. Supposed to be a different minus P square. Okay. So this is the format they want you to put the answer. See? This is the format they want you to put the answer. Every time you have quadratic, this is the format you put the answer. Okay? So we're supposed to have this format, put it in this format, which is x plus p. This is called completed square form. I did minus q, we use another letter, minus q. Okay. Or minus p, whatever they use. This is called completed square form. This is called what? Completed square form. This is not the completed square. We've not finished the completed square, because this is an expression. This is called completed square form. This is called completed square form. So there's a difference between put it in the completed square form and solve the uses of completed square. Completed square form means you should just reach this level and stop. Completed, no, not completed square, completed square. Completed square form. Completed square form. Okay, so this one is called the completed square form. Writing it in this format, like this one, stopping here, is called completed square form. Sometimes they ask you to leave it in completed square form, and then you stop there. Okay, this is a part of the question. Normally, when they want to ask, they say put in the completed square form. And then the second part of the question, they say if this is equal to 0, the b, find the value of x if s square plus 10x plus 9, see, it's the same thing, equal to 0. Okay, now they just equate it to 0. If you look at it, this is the same thing that they've given to us, s squared plus 10x plus 9. But they did say equal to 0 in the first case. So this is an expression. So in expression, we stop at the completed square form. Now they want you to solve it as an equation. So as equation, find x. Find x. So as equation, what we do, we don't have to start from the beginning, because it's the same thing. We don't have to start from the beginning. You just continue from where you stopped here. You just bring this one, you translate this one, you say, you bring this one to this junction. You say, at this point, you borrow this one. Because it's the same equation. They just equated it to 0. So you just say x plus 5 square minus 16 equal to 0. Just since they equate it to 0, and this one is what you'll be solving before. So where you stop, just bring it down. Bring it down. Bring this one down where you stop. Bring it down here. Because it's the same equation. They just equated it to 0. Same expression, they just equated this one to 0. Now the next thing to do to continue this, to find the values of x in quadratic, you move negative 16 to the right side. That's the next step. Move negative 16 to the right side. We move negative 16 to the right side. So what I have next will be x plus 5 square, okay, square both, x plus 5 equal to, I move negative 16 here, become positive 16. I move it to the right, become positive 16. Then the next thing to do is to remove this square. In order for us to find x, I have to take the square root of both sides. So we say take square root of both sides. Take square root, I abbreviate square root of both sides. Of both sides. So when you do that, it means I'll have x plus 5 square. This is what we have, x plus 5 square equal to 16, right? Then I will take the square root of both sides. Now let's take another color to take the square root. Let's say I take the square root of here. I also take the square root of here. In mathematics, once you take square root, you get plus minus. Because, for example, minus 4 square will give you 16. Plus 4 square will give you 16. So you must get plus and minus for both sides. So this square root normally cancels square. Square root cancels what? Square. Square root, this square root will cancel the square. They cancel themselves out. But in fact, that's the reason why we took the square root of both sides, to be able to cancel the square. So square root cancels squares. Then we have x plus 5 left. We have x plus 5. Okay, yellow is not conspicuous enough. Let's change yellow to, we have x plus 5. Square root has cancelled the square. No more square root, no more square. Equal to, what's the square root of 4? 16 plus minus 4, right? Equal to plus minus 4. If you take the square root of 16, you get plus minus 4. Why? Because negative 4 square, if you say negative 4 square, you get positive 16. You get 16. And positive 4 square, you also get 16. Positive 4 square, you also get 16. So if you find the square root of 16, you actually get it to number. In other cases, we don't write the two number. We don't write the plus minus. But for quadratic, you have to show the 2. Okay? Because that's actually what it is. Now the next step, in order to find two answers for quadratic, you know in quadratic you must get two answers. So the next step is to say x equal to, you move 5 to the right. If you move 5 here, it becomes positive 5. So I'm going to have plus minus 4, then minus 5. Okay? Now to get to answer, we say x equal to plus 4. I will separate this plus minus. I will separate 4 into 2. I will have plus 4 and I will have minus 4. In the first instance, I will say plus 4 minus 5 or minus 4. I will now use this minus. Minus 4 minus 5. Minus 4 minus 5. So we get x equal to plus 4 minus 5, we get negative 1. And minus 4 minus 5, we get negative 9. So these are the two solutions to this quadratic. Is that okay? These are the two solutions to this quadratic. Is that okay? So this is how to solve completely the square and completed square form. This is how to solve completely the square and how to solve completed square form. So more problems, but we follow the same pattern. More problems, we follow the same pattern. So let's say What if we have a factor behind? We have a factor, a number, but okay, before we do that, I think we should do ordinary one first. Okay. What if we give you this? They say a square term. Let's say we'll give you this one. They say put in the completed square form, or probably find the value of y. Find the values of y. So this one we can solve also, and by taking x squared plus 6x minus 3. Okay, x squared plus 2 x squared plus 6x. Okay, this one will just be fast in the solving because the first example was for explanation. Okay, they say y equal to this. Say y equals to this. If you give you this, what we do, we have the coefficient of x. Okay, we have the coefficient of x, so we have x squared plus 6x. So when we have the coefficient of x, we get 3. 6 divided by 2, we get 3. We square it, we add it here, it becomes 3 squared. We subtract it from here, minus 3 squared. Minus 3 squared. So we add it here and we subtract it from here. And then the next thing, we solve this and this together. Okay, we factorize this by writing x. We say x plus 3 because of this plus 3, and then because this is square, this one is square, and this one is also square, we square both of them. And we said if you expand it, you're going to get this one back. You know, here means 9. 3 squared is 9. So you're going to get this one back. If you expand this, you get this one back. Okay, so minus 3 minus 9, right? Why? Because we are squaring only 3, not minus 3. We only subtracted it from here. We are squaring only this one. So it becomes what? 12, negative 12. So you have s squared plus 3, s squared, s plus 3 squared, and then minus 12. Minus 3 minus 9 is negative 12. So this is the completed square form. So if they ask you to solve it and put it in the completed square form, this is what you get. This is what you get. Okay, this is how to put it in the completed square form. But if they want us to find the solution, they will say this is equal to 0. Okay, for example, if it's equal to 0, then we start to equate this one to 0. Okay, if it's equal to 0, we start to equate this to 0, and then we move the negative to the right. So we have s squared. We have x plus 3 squared. We have x plus 3 squared equal to, you move negative 12 to the right, become positive 12. And then the next thing to do is to take the square root of both sides. Why? Why we taking the square root of both sides? So that we can eliminate this square. Because if you don't take out this square and this bracket, you'll not be able to solve it. So you say you take square root of both sides. So I'll just write SQRT, square root, both sides. So I'm not writing that on the board. So we move on to saying this becomes x plus 3 in one bracket, square, equal to 12. So I take the square root of both sides, square root here, and I said when you take this square root, you should put plus minus. Put plus minus here. Okay, so square root we cancel square. Here square root we cancel the square. Square root we cancel square. So what we have left is x plus 3. What we have left is x plus 3 equal to plus minus root 12. Okay, someone please press the square root of 12. Square root of 12. Quickly, square root of 12. And then you have x while I'm waiting. X equal to, I move plus 3 here, become minus 3. So it become minus 3 plus minus the root of 12. Plus minus the root of 12. I just move this plus 3 to the right, become plus minus the root of 12. So our answer will be x equal to negative 3 plus the square root of 12, whatever we get as the square root of 12, or negative 3 minus the square root of 12, whatever we get as the square root of 12. Square root of 12 is 3 point something. Okay, 3.46. So we have x equal to negative 3 plus 3.46 or negative 3 minus 3.46. So we have x equal to this plus this, you get 0.46 or negative 6.46. So these are your two solutions. It's just for you to solve more. It's very easy. Just practice and then that's it. It's very easy to do completely the square form. Okay? So we have another one. It's a s squared plus 6x minus 11. S squared plus 6x minus 11. Let's try this also. Well, this time around I will say equal to 0. I'll solve it as equation. Okay? I'll solve it as an equation. Right? We solve it as an equation. The one with the coefficient at the back, it's for A level. Okay? Let's take this one, s squared plus 6s minus 11. Question number 3. And after this, we're done with this completed the square form. S squared plus 6x minus 11. So I will just say equal to 0. Make it an equation straight away once and for all. Okay, now what we should do, like I said, whenever you have this, what you should do is we'll normally break this into two segments, so that we can add and subtract if they are both on both sides. Okay, if you're doing it on both sides. But if you move this one to the right, you add and add to the left, add to the right. If we move the level straight away from the beginning to the right, we're going to add to both sides. But if you're solving this from the left, both of them on the left, you add to this, you subtract from the coefficient of x. Now we're going to have the coefficient of x. So it means the coefficient of x is 6. So when we have it, you say 6 divided by 2, we get 3. So we square it. The next step is to square that coefficient. So we're going to be adding the square of the coefficient, half of the coefficient of x. So here I write my s square, the whole package. I write this whole package. S square plus 6x. Okay, I write the whole thing, my first block. And then I will add this. 3 squared. I'll add it to this side. So let me use different color to show that it's something different. So I say plus 3 squared. Then I'll say minus 11. Then I'll subtract the 3 squared here. Subtract. Remember this one, this minus is not part of this 3. Okay, it's separate. It's separate. So what we have equal to 0. So what we have is we have s squared. I say whenever you have this, just take this and this. and put them together. Take x, whatever sign is here, if it's plus you write plus, if it's minus you write minus. Then just come straight to this number, write the 3 and put them together and square both of them. Then I went further to say if you expand this, you see that this factorization, you just do a trick to factorize this. What I just did was to factorize this, but it's a trick. Just take this x, take this 3, put them together, square both of them. If you expand this, you get this back. Okay? Then minus 11, then minus 9. Because you're not squaring this minus, okay? It's not part of what you're squaring. It's not a negative 3, it's 3. So you square only the 3. The minus is like you're just subtracting it from here, that's it. So you say minus 9 equal to 0. So we move to the next step. We say x plus 3 square, x plus 3 square, minus 11 minus 9, that's negative 20, right? This is negative 20. If they ask you to put in completed square form, this would have been your answer. You know, when they ask you to put in completed square form, it's like this. They say this format. Let me use another coloration to show, to distinguish it. If they ask you to put in completed square form, they say put in the form x plus p square, in the exam minus q. Then they ask you what's the value of p and q. They ask you what's the value in the exam. Because in the exam they ask both questions. They give this as A, and then they want you to solve the B as equation. So the A, they ask what's the value of P. In this regard, our value of P is what? Our value of P is 3. Our value of P is what? For this question, the value of P is 3. And the value of Q is negative 20. Okay, let's say this plus P plus Q. The value of Q is negative 20. So in the exam, they ask you what is P, what is Q. So you simply say P equal to 3. But if here was minus, you say P equal to negative 3. If here was negative, you say P equal to negative 3. But in this case, P is 3. So you say P is 3 and Q equal to negative 20. For this, with regards to this question, Q equals to negative 20. Because they normally in the exam in Cambridge, they normally tell you to put in the completed square form, which is this format, and then they tell you what's the value of P, what's the value of Q. So you just take the one in the bracket, the number in the bracket as P, and sometimes they don't use P and Q, they use A and B. They say put in this format, x plus A square. So it doesn't matter what they use, what letter they use. It doesn't matter. It's same concept. Okay, plus B. They can put in this format. And then they ask what's the value of A. A in this regard is 3. And B in this regard is negative 20. Is that okay? So it doesn't matter. Once they ask you to put in the completed square form and they ask you the value of A and B, you just take it from this completed square form after finishing the completed square form. Now the second part of the question is to continue this one. To find the equation. To continue this and solve the equation and get the two values of x. To continue this equation and find the two values of x. Now, in doing that, we quickly resume our work. We say x plus 3 in one bracket square minus 20 equal to 0, right? So we move the negative 20, we move it to the right. We move the negative 20 to the right. So we have x plus 3 square is equal to, I move the negative 20. This negative 20, I move it to the right, become positive 20. So it becomes positive 20. The next step is to eliminate this power 2. Eliminate this power 2. And in doing that, I say you take the square root of both sides. In order to be able to eliminate the power 2, to take out this power 2, is to take the square root of both sides. So I'll just write SQRT. So you know exactly what we're supposed to do. SQRT meaning of both. SQRT both sides. Both sides. SQRT both sides. Meaning take the square root of both sides. So then it becomes like this: x plus 3 square x plus 3 square equal to 20. There I'm going to take a different color to show the square root of both sides. So I put my square root here, I put my square root here, and I say for this constant number, when you put square root you have to put plus minus. You have to put plus minus with it. So this one, the square root, every time you have square root cancel square. If it's cube, if this one was cube, you take the cube root of both sides. If this power was 3, you take the cube root of both sides. Cube root will cancel cube. If it's 4, this power 4, for example, you take the fourth root of both sides. If it's here is power 5, I'm just explaining a concept. I'm not saying for this question, quadratic, you don't have any power above 2. Then when you solve your other mathematics and you find power up to power 6, you take the 6th root of both sides. Okay? Not for the case of quadratic. For quadratic, you're only going to have power 2. So this square root cancel this square. So what I have left is x plus 3. X plus 3 equal to the root of 20. Can you find square root 20? Let's find square root 20. You're going to get 4 point something. You're going to get 4 point something. So let's find square root of 20. Is that okay? So then we say x equal to, I move the 3 to the right. It becomes -3. -3 plus minus root 20. Plus minus root 20. So we find root 20, we add it to -3 and we subtract it from -3. Okay, so we have x equal to -3 plus 4.72 or -3 minus 4.72. So this gives us 1.72 minus 3 plus 4.72, you get 1.72, right? Or minus 7, or minus 7.72. Minus 7.72. So this is the solution, the two solutions. You see, all these decimal answers means factorization cannot solve it. We either use quadratic formula or use complete square method. Complete square method is very easy to use and you just have to practice. So with this we come to the end of completing the square method, and I hope that you do understand.